Why nanoscience is attracting so much interest? The fundamental properties of materials changes at the nanoscale. The properties of atoms and molecules of a nanoscale are governed by the principles of quantum mechanics. The physical and chemical properties of nanoparticles can be quite different from the bulk materials of the same substance. The properties such as color, solubility, material strength, electrical conductivity, magnetic behavior, mobility, chemical reactivity, and biological activity might change when the size is reduced to nanoscale. Moore's laws, there are two statements in this Moore's law. The first law states that the amount of space required to install a transistor on a chip shrinks every 18 months. This means that the spark that could hold one transistor 15 years ago can hold thousands transistors today. The second law states that the cost of fabricating a chip doubles with every new chip generation for every 36 months. Then, when the particle size is reduced, consequently, the percentage of surface atoms will be increased. Next slide. There are few properties which might change on depending upon the size of the particles. The properties like chemical properties, in that the reactivity and catalyst will be changing when the size is reduced. Then the thermal property like melting temperature will change when the particle size is reduced from the bulk to the nanoscale. Then mechanical property like adhesion will tend to change when the material property is changed from bulk to nanoscale. Then optical properties like absorption and scattering of light will also change from bulk to nanoscale. The electrical property like tunneling effect will also tend to change. Then surface effect. When the particle size is reduced from the bulk to nanoscale, the percentage of the surface atoms will be increased. This table reveals that point. Then when the particle size is reduced, correspondingly the percentage of the surface atoms will be increasing. Here, this picture evidences the bulk material. From that, we are cutting the material and we are reducing the size. Here, the surface atoms percentage is increasing. The third picture, further we are cutting the particle size, then here the surface atom percentage is more increased. Okay. Why we need more percentage of surface atoms to contribute to the nanoparticles? Here, whenever there is a percentage of surface atom is increasing, the more number of particles will be in contact, so that the reactivity will be increased. There are basically three quantum structures. One is a quantum well, then quantum wire, and quantum dot. The quantum well, when the dimension is reduced to nanoscale, only one dimension is reduced to nanoscale, and while other two dimensions are remaining in bulk range, means that structure is a quantum well. Here in quantum wire, two dimensions will be reduced to nano range and one dimension will be remaining in bulk. That structure is quantum wire. Even all three dimensions are reducing to the nanometer range, then that structure is a quantum dot. Here the table reveals the delocalization region and confinement region. When it is a bulk material, the delocalized direction will be 3. The confinement direction will be 0. In quantum well, since we are confining only one dimension to a nano range, the confinement direction is 1 and the delocalization region will be where in quantum wire, since one material is one dimension is reducing to a remaining in bulk, and 2 dimension are confining to a nano range. The 1 dimension is delocalized and other 2 dimension is confined. Then all 3 dimensions are reduced to nano range in quantum dot. So confinement direction is 0 and delocalized direction is 0. Sorry, confinement direction is 3 and delocalized direction is 0. Here in density of states, as the particle size reduces, the energy level distribution will be continuous. Then the discrete nature will be increasing as the particle size is reducing. Here in 3 dimension, the energy distribution is continuous. When the particle size is reduced to 2D structure, the discrete level will be increasing. In 1D structure, more discrete nature will be observed, and 0D structure, the complete discrete nature is observed. Fabrication, there are 2 basic fabrication techniques. One is top-down approach and another one is bottom-up approach. In top-down approach, the bulk material by successive cutting and slicing reaches a nanoscale dimension. All physical methods of top-down approach. The typical examples are lithographic technique and bond milling. Bottom-up approach. The bottom-up technique is an approach to synthesis nanostructure by growing atom by atom or molecule by molecule. All chemical methods are bottom-up approach. The typical examples are self-assembly, sol-gel technique, solvothermal synthesis, and hydrothermal method. There are several applications. The polymer can be used as a treatment of wound. Conducting nanofibers may be used in fabricating small electronic devices such as sensors, batteries, and photovoltaic devices. Carbon nanotubes are best field emitters. Then carbon nanotube can be used as switching devices, interconnect wires, and memory devices. Boron nitrate nanotubes can be used as insulators. Molybdenum and tungsten chalconite nanotubes is used as solid lubricants.